Okay, everyone. So our next section here is looking at microscope basics. So this is part of the grade 9 AP Prep extension. It's also part of the grade 10 curriculum. So you will see this again in grade 10. Obviously, right now, due to COVID restrictions, we're not able to use the microscope, and also you're virtual right now, but there's an online simulator that's actually really nice, and hopefully next year in grade 10, I'm hoping everyone will get to use the microscope. So the study of microscopy is essentially, it's a branch of biology that the whole study is essentially using microscopes to view samples or different living species or different objects. So essentially they are microscope specialists. Now there's many different parts and components to a microscope. So we'll kind of go over each of these. When you are holding one, and you'll see that we have this point here, you always want to carry with, I'm going to erase this after, but imagine there's like one hand here. Oh gosh, that's awful. And one hand on the base. So when you're holding this and the person's body is here, sort of. Okay, so you hold one hand on the arm of the microscope, one hand on the base. So you always hold the microscope with two hands whenever you are using it. Okay, so again, that'll become important when you start using it. So let's talk about the different pieces. So there are two lenses that help us to enlarge the organism that we're looking at. So there's a lens in the eyepiece. Okay, so it's called an ocular lens, but it also goes by the term eyepiece. And we also have objective lenses. Okay, so there are most microscopes. So this is a light microscope, and most high schools and some elementary schools have these as well. So there are 4 different types of lenses that are here. And this basically will rotate around. Pardon me. This will rotate depending on the amount of magnification we want, like essentially how big do you, how enlarged do you want the species to be. So how this rotates around is actually on this piece. This is a nose piece. Sometimes it's called a revolving nose piece because this can twist and you can move the different lenses around. Okay, so this section here, this section here is the body tube. So this is where it connects essentially the lens to this main section where the objectives are. So the reason for this distance is important because you need a certain amount of distance in order for the lens to do its job with enlargement. Okay, so the arm, as we mentioned, is where you essentially hold on to while you are walking with the microscope. Now this black portion here is called the stage. So it's kind of like your species is, let me get a nice bright color here. So your species is like the star of the show, and the stage is where you're going to put it. So your glass slide where you would have the specimen will actually fit right here. So that you are essentially where my X is where the specimen would be that you want to look at. So you put the glass microscope slide onto the stage and you hold it in place using stage clips. Maybe you can't even see that because I have it drawn over. But it's these metal pieces here. So it just holds them in place. Okay, so we have a light. So again, we mentioned this is a light microscope. So the light that's there turns on, obviously, and the light shines through up here so that we can see the specimen nice and bright. Now, there is a dial here that you can turn. Okay, the diaphragm allows you to control how much light is going into the lens, pardon me, the slide that's up here. So you can have all light, you can open it up all the way, or you can dim it so you can have a smaller amount of light. And really it just depends on what will give you a better view. Okay, the base, which is the bottom part, is the other portion, right? It's what's holding the microscope together. And it's the other thing that you're going to hold on to when you're holding onto the arm. And there's 2 knobs. Okay, these are important. So this is what we're going to use to try and focus our image of our specimen. So we have a coarse adjustment knob and a fine adjustment knob. you always use the coarse adjustment knob first. So turning this knob will basically move this stage up and down. Okay, so it moves it up and down. So that way you want to make sure you're looking, so imagine your eye would be here. Okay, so like a person's eye, okay, would be there. It's awful. But so look, somebody's looking into this, and you would be turning this coarse adjustment knob until you start to see the specimen that you are looking at. Once you can see it, then you use the fine adjustment knob. This is like you're fine tuning it. The coarse adjustment knob is just to actually see something there. Then the fine adjustment knob is to make it a nice clear image. So you never use the fine adjustment knob first. This is just where you are trying to focus it in small increments. You always use the coarse adjustment knob first. Okay, so how do we take care of it? As I mentioned already, you carry it with 2 hands. You only use lens paper. If the lens is dirty, you never use like a regular Kleenex. We have special paper for it. Don't force the knob. So if you're trying to turn the knob and you're cranking it and it's not moving, that means you're at the end of the option to move it. So don't keep cranking it. Don't force it to keep going. It's obviously already stopped. When we store it, we always store it with a cover, because what can happen is if you have dust, dust will accumulate on here, and essentially it will dirty the lens and cause damage over time. Okay, and of course you want to make sure that you have no clutter around. So what are 2 things that we look at when we're using microscopes? So the whole point is we want to produce a large, clear picture of whatever we're looking at. So there's 2 factors: magnification and resolution. So magnification is essentially talking about how we are making the size of the image bigger, right? So we're taking something small like a bacteria and we're making it look much bigger by using the lenses. And resolution is what we use that fine adjustment knob for, and that's so we can make a nice, clear, focused picture. So to calculate the magnification, make this a bit thicker. So remember that the microscope has 2 lenses, the eyepiece lens and the objective lens. So how we can calculate the magnification is you take the eyepiece magnification and you multiply it by the lens that you are using on the objective side. So here's an example. So the total magnification is the ocular lens times the objective lens. The ocular lens is always 10 times magnified. Okay, so this is the ocular. Okay. The objective lens is going to be different depending on which one you're using. Remember, there's 4 different options. So it will always be written directly on the side. So here, this is an objective that's 40 times magnified. So for this particular example, if we have the ocular is 10 and the objective we're using is 40, that means our total magnification is 400 times. So that means when we're looking at our specimen, it's been essentially zoomed in 400 times. That's what that means. So let's say, it depends on what this is. So let's say this one instead of, okay. So let's say instead of 40, this was, 10. So then we would have 10 times 10. So that would be 100 times, right? So this is always 10. But this objective can change. It depends on what part of the microscope you're using. Okay, so magnification is actually very important. So here's just to show you an example. So here we have A and B. So you can see B is actually a magnified version of the same slide, except it's this small portion here. So obviously for B, we're using a much bigger magnification value. Okay, now resolution is essentially, remember we're talking about the clarity of the picture. So making sure it's a nice, clear, focused image. So here we have, and you can see this one's really nice to see. The left side is an unfocused or has very bad resolution. And on the right-hand side, we have a little bit of a, it's not perfect, but it's much more clear than it is on the left. And here's another good example. So obviously, the best type of image is to have a very magnified image. So we want to have this magnification, but we want to make sure that it has high resolution. So the best type of image is high magnification and high resolution. Okay. So I've already went through this, so I'll leave this for you to read through on the notes, but it just talks about how to go about using the microscope. And of course, during the simulator, there's actually a virtual tour that will show you how to use it. But the biggest thing is to make sure that you use the coarse adjustment knob first and then the fine adjustment knob, because you can actually damage the microscope if you go the other way around. Okay, so be careful when you are using the most powerful magnification. Sometimes what's going to happen is it's actually too close, so you won't even be able to see what you're looking at. So it's funny, a lot of people want to have like the biggest zoomed in picture possible. Maybe if you've ever zoomed in on a picture, like zoom in really, really close, you won't even be able to tell what you're looking at. So sometimes having less magnification is the better choice. So, yeah, so this is kind of very repetitive here, right? So your slide has to be focused on a low power first. Do not use the coarse for focusing, right? You want to use coarse adjustment knob and the fine adjustment knob for when you're trying to focus your image. Okay, so after you look at the microscope, you can do what's called a biological diagram. So I'm going to show you examples of them. So normally if we were in class time, so if you're watching this and we're not in COVID times right now, we will do a biological diagram. But unfortunately, if you're doing this virtual, you'll do this in grade 10. So don't feel like you're at a disadvantage here. You're going to learn this again in grade 10. So it is repeated. Okay, but I do want to show you what it looks like. This is a bad scan, but essentially what you do is, so here is what it looks like when you're looking at the microscope. See how it's like a circle? Sorry, I'll erase it. So the circle is like the viewpoint of the person looking into the microscope. Now, notice a couple of things. The magnification is written. So it's telling you that this image was made at 400 times magnification. So probably it was the ocular of 10 and then 40 for the objective, right? So that's how they got the 400 times zoomed in. Notice that they have labelings all on one side. So, and they're using a ruler, like a nice straight line. So they're labeling the different parts. This is a paramecium. So they're labeling the different parts of this organism on one side only. Okay, for all the different labelings. So you don't want to have like random labelings all over the place. It's always done on one side. Okay, and always the lines are made with a ruler. Here's another example. So this is actually from a student in my class a few years ago. Ooh. So the title is there. So again, so this is actually 40 times. So yeah, sometimes like this is a beautiful image. So the labels are all on the right-hand side. It could stand to be a little bit straighter, but you can see that they did use a ruler to do the labeling. So this must have been a 10, because the ocular is always 10, and then it must have been the 4 objective to get to 40, right? So notice that they're always using pencil. So you never want to use pen when you're doing this. So this is called a biological diagram. Okay. Also, to do the shaded areas, they use a technique called stippling. And what that means is instead of shading something, you use dots to actually create the shade. So you can see here, there's like a bunch of dots around. The reason why is because they're shading in this area. So they put in a bunch of dots with their pencil to show that it's a darker region. Okay, so just to show you some examples of biological diagrams, there you go.